Hi, my name is Giorgos Hadjipavlis and I'm a senior researcher at iSense Group, a research center of the Institute of Communication and Computer Systems, ICCS, of the National Technical University of Athens, Greece. In this course, we will try to break down the data spaces and urban mobility ecosystems into the simplest term and easy to understand explanation. So, let's dive in. Data spaces are digital ecosystems where data is shared, accessed, and managed securely across multiple stakeholders. They are collaborative platforms that connect governments, organizations, businesses, and individuals, allowing them to exchange data in a transparent and efficient way. But data spaces are more than just software technology. They are a new way of thinking about sharing. Instead of keeping information locked away in silos, data spaces encourages openness and encourage joint efforts. By consolidating data into a single environment, data spaces create a foundation for comprehensive insights, enabling a unified approach to solving complex problems. As cities grow and technology advances, urban areas around the world faces two major challenges: upgrading transportation system and meeting the increasing mobility demands of their citizens. A key solution to these challenges is the creation of mobility data spaces, where urban mobility stakeholders, government, transit operators, private companies, city planners, and citizens can collaborate on a common goal: to provide an efficient, intelligent transport system that will benefit both the city's economy and enhance the quality of life of its residents. Furthermore, a minimum set of shared vehicle data, following the business-to-business and business-to-government model, could enable safety-relevant services, facilitating moving to zero fatalities in road transport by 2050, as envisioned by the European Commission. With a definition in place, let's explore the key features of data spaces. Data is the core of any data space. It can be gathered from a diverse set of data sources, such as community traffic sensors, GNSS devices, public transport logs, crowdsourced mobile applications, and feeds such as social network or weather forecasting services. For example, sensors on a bus can track its location and speed, while weather sensors and crowdsourced apps can provide data for the road condition on the bus route. Social media can offer real-time updates on accidents or road closures even before authorities being notified. Secondly, data governance is a fundamental aspect of managing data spaces effectively. It involves the establishment of comprehensive policies and procedures to ensure the quality, security, and regulatory compliance of data. Its aim is to create a structured framework that governs how data is collected, managed, and utilized across the entire data ecosystem. At its core, data governance defines the common data format that all participating entities within a city must adhere to. The standardization is crucial for ensuring that data from different sources is compatible with the platform and can be interchanged seamlessly between users. Moreover, data governance encompasses the development of protocols for data management. This includes establishing procedures for data collection, storage, processing, and dissemination. The protocols ensure that data is consistent, accurate, up-to-date, and reliable. They also help in maintaining the integrity of the data, preventing errors, and ensuring that the data remains usable over time. Access control is another critical component of data governance that defines who has the right to access and modify the data within the data space. This can include role-based access control, where different users are granted varying levels of access based on their roles and responsibilities. Establishing guidelines for responsible and ethical data usage is crucial. For instance, ensuring that data usage complies with privacy regulations and does not infringe on individuals' rights. It is also essential to set boundaries on data sharing and usage to prevent misuse or exploitation. Third major feature of a data space is data integration. An advanced database management system is essential for effectively managing the incoming influx of data. Usually, data spaces are based on a permissioned centralized database SIEM, which offers greater throughput and better access control. However, permissionless decentralized SIEMs are gaining traction due to the advent of distributed ledger technology, providing enhanced data resilience, transparency, and immutability. Data integration is a critical process that involves collecting data from various sources and ensuring its consistency and usability before further processing. Raw data streams, which are typically unformatted, are standardized according to a common data format specified by dataspace governance. Additionally, this data is stored in data lakes, centralized repositories where data is accessible for historical analysis and evaluation. By adhering to these standardized formats, cities can maintain data consistency and interoperability. As urban areas expand, both data volumes and involved partners increase. Therefore, it's crucial that the system can handle this growth efficiently. Thus, scalability is a factor that needs to be tackled by data spaces. Techniques like data partitioning and replication are used. This ensures that data remains accessible and the system performs reliably, even under heavy load. What are the major benefits of data spaces for urban mobility? Let's see. With real-time information at their disposal, traffic managers and public transport operators can adjust traffic lights timings according to the current traffic conditions, giving priority to public buses, reroute traffic to alternative paths to reduce congested road networks, or maintain a minimal low-speed traffic movement to reduce vehicle idling time. City planners can reorganize road networks and improve infrastructure development based on historical data analysis of vehicle traffic flows, supply chain logistics, and residents' transformation patterns. Citizens can gain access to real-time information about traffic conditions, public transportation schedules, and alternative routes. This empowers them to make better informed decisions about their travel plans, leading to a more convenient and seamless urban mobility experience. Additionally, they can be informed on smart mobility solutions such as on-demand ride-sharing services and electric vehicle charging station availability. But how we are building and maintaining these data spaces? We already covered where data are gathered from, how they are processed, and where they are stored. But the goal of every data space is to build trust among its users, especially as far as the platform's security is concerned, as well as to facilitate accessibility and collaboration among users. Robust security measures are essential to prevent unauthorized access, data breaches, and cyber attacks. Data integrity must be maintained to ensure that information remains accurate and unaltered. Adhering to data protection regulations, such as GDPR, is also crucial for compliance and to protect the privacy of individuals. Implementing strong encryption, access control, and regular security audits are fundamental to safeguarding data within mobility data spaces. Data anonymization techniques must be employed to remove personally identifiable information, ensuring that individuals' identities are protected. Access controls restrict data access to authorized personnel only, minimizing the risk of data misuse. Obtaining explicit user consent for data collection and usage is essential for transparency and trust, but trust is also affected by the relation between the stakeholders. Authorities and public agencies are the main users that establish policies and regulations to govern data collection, sharing, and utilization, ensuring that data spaces operate within a legal and ethical framework. Also, they provide financial support and resources to facilitate the implementation of data spaces initiatives. Public engagement, which is crucial for gathering input and feedback from citizens, should be incentivized to ensure active and meaningful participation. On the other hand, private companies and individuals play a crucial role in developing and deploying new technologies and solutions for data collection, integration, and analysis. Examples include smart sensors for traffic monitoring, AI applications that analyze telematics data for buses to create probabilistic predictive maintenance patterns, mobility as a service mobile apps, and car sharing applications. Other applications may also include cooperative road usage, targeting minimization of safety-critical events among vehicle and vulnerable road users, bicyclists, pedestrians, motorists, caused by hazardous road user interaction. By sharing relevant data with public entities, private sector stakeholders contribute to a comprehensive data ecosystem. Additionally, investment in data infrastructure and mobility solutions by private companies is essential for the ongoing development and success of data spaces. So, let's see some examples. Smart traffic management in Barcelona. Let's take Barcelona as an example, which uses Sentillo platform for smart traffic management. The Sentillo platform is an open-source sensor and actuator network that collects real-time data from various sources across the city. This data includes information on traffic flow, noise levels, air quality, and more. By analyzing this data, traffic managers can make informed decisions to optimize traffic signals, reduce congestion, and improve overall traffic management. The platform also supports public transportation by providing real-time updates and rerouting options to avoid delays. This holistic approach to traffic management helps create a more efficient and sustainable urban environment, and according to platform results, city authorities managed to reduce emergency response time by 25% and cut downtown traffic by 20%. Meanwhile, Singapore has developed a digital twin of its entire transport network, utilizing real-time data from buses, taxis, and traffic lights. This digital simulation allows the city to predict and manage various scenarios such as monsoon floods and large festival crowds. Through predictive congestion algorithm, the city implemented dynamic toll pricing in the city center, which has successfully reduced peak traffic by 30%. Additionally, Singapore launched a user-friendly mobility as a service application, allowing 60% of users to easily combine walking, public transport, and ride shares in one trip. Furthermore, Melbourne tested IoT-enabled trams in one district before scaling citywide. The goal was to evaluate how real-time data collection and analysis could improve tram operations and passenger experience. Sensors installed on the tram monitor everything from speed and location to passenger count and mechanical performance. Lastly, Boston adopted the Street Bump app, a crowdsourced mobile application that uses accelerometers and GNSS sensors in smartphones to detect bumps and potholes as vehicles drive over them. While initially designed for individuals, the concept has been adapted for use in public transport systems, including buses. The case studies demonstrate how some big cities have successfully implemented data-driven solutions to improve urban mobility. These examples illustrate that overcoming challenges such as data privacy, interoperability, and stakeholder resistance requires careful planning and collaboration. Best practices include robust stakeholder engagement, investment in scalable and interoperable systems, and continuous monitoring and evaluation. Cities that adopt these strategies can successfully implement data spaces, leading to enhanced decision-making, improved traffic management, and more sustainable urban environments. As we look to the future, building on the lessons learned from successful case studies, let's explore the emerging trends, technologies, and policies that will shape urban mobility. 3 trends will redefine urban mobility. First, 5G, Internet of Things, and ADAS systems will enable autonomous transportation agents. Second, digital twins will simulate entire cities and analyze city road networks under edge cases traffic scenarios. And third, drones will shift some transportation from ground to air, especially for urgent deliveries like medical supplies. Imagine a city where AI can not only optimize traffic flow, but also predict and mitigate potential disruptions. Autonomous drones may deliver goods and emergency supplies, reducing congestion on the roads, guided according to rules generated by AI traffic management. Or a city where every street light, bus stop, and even park bench is part of an interconnected network. Smart infrastructure will seamlessly communicate to provide real-time updates to citizens, such as availability of parking slots, parking transportation schedules, or air quality alerts. Also, future policies will focus on fostering innovation while ensuring ethical standards. Updated regulatory frameworks will integrate the rapid deployment of autonomous vehicles, and public infrastructure predictive maintenance performed by reputable local authorized individuals who will be compensated with digital currencies based on community feedback. The future looks bright for the mobility as a service sector, which promises to seamlessly integrate various transport modes like autonomous buses, ride-sharing pods, e-scooters, and even flying drone taxis. This platform will operate within city limits, personalized to individual transportation patterns, and collaboratively coordinated by AI agents operated by the city's mobility data space. Urban mobility is not just about moving people. It's about driving economic growth, protecting the environment, and ensuring fairness for all. By using data spaces, cities can improve traffic flow, offer mobility cloud-based services, including safety-related services, cut down the pollution, reduce expenses, and make sure transportation system works for everyone.